Hey, welcome back to some more math practice. One of the skills required to understand this idea is the good old distributive property. The other one comes in the form of a puzzle. I like to call it which two numbers. We have two charts here, or two tables. They work the same way, okay? On one column, we have, think about two numbers that multiply to all of these values here. And we must think those same two numbers combine to the corresponding value on the right side. Same here. This is the multiply to 36 and combine to negative 12. What do I mean by combine? I mean either the operation add or subtract. Because remember, sometimes when we subtract, that's still a form of addition. Like 5 minus 3 is still a sum. So I'm going to call that a sum. Really, that's what we should be thinking of. And multiply, you heard that before, that's called a product. And if you haven't, then those are just interchangeable phrases to represent the same thing, all right? So let's do one together, and then I'll give you time to pause if you need to try it yourself in case you're still a little confused. Let's think of two numbers. What two numbers can multiply to a 21, but those same pair must combine, meaning the sum is 10. Two numbers multiply to 21, and they combine to 10. I'm thinking of 7 and 3, and I'm thinking of the product first, or the multiplication first, because there are fewer choices. We can narrow it down to fewer choices by thinking of the product first. So let's check that. 7 times 3, and I just separate them by a comma. 3 comma 7 would be the same pair, right? So 7 times 3 is 21, and 7 plus 3 is 10. That checks. We can easily check that. There's no other way to around it. No need to use a calculator. You can check yourself, and you can check with the calculator if needed. All right. If you need some time, you know what to do. Otherwise, we're going to check them now. All right. So let's do that now. Okay. So I'm thinking two numbers that multiply to a negative 12, and those combine to 4. So here's an instance where to multiply to 12, we know one of them must be a positive number and the other one a negative. And that sum is 4. Okay. So I'm thinking something like 6 and 2. All right. 6 and 2. And I'm just skip a lot of the thinking and just write the answer. 6 and 2. But we know one of those has to be a negative. Which one was negative? It looks like negative 2. If we're going to get a positive 4 as the sum. 6 minus 2 is 4. There we go. All right. Same thing. Product of 30 negative 35. That tells me one number is positive. The other one is negative. So something multiplies to 35 and can make some form. It can make a negative 2. So I'm thinking some form of 7 and 5. Can some form of 7 and 5 multiply to 35? I'm sorry, negative 35? The answer is yes. So remember, one of them has to be negative, the other one positive. If the sum is negative 2, that means the larger number was negative. And you can check, negative 7 plus 5 is negative 2. And this product is negative 35. Great. All right. Now this one's interesting because we've seen positive product before, and it was the same kind of symbol. But now it's a little bit different because the sum is negative. So it's got to be the same symbol and the sum is negative. That means both numbers must be negative. Hopefully you're thinking about that. And what do we have here? I'm thinking some form of 6 and 4. But remember that it's got to be both the same symbol. To make a negative 10, both of those have to be negative. If you thought of it as negative 4 and negative 6, that's fine. The order doesn't matter here, okay? I'm just listing them, whatever came to my mind first. All right, something multiplies to a negative 30, combines to a 1. I'm thinking something like 6 and 5, or 5 and 6. So you can see the order doesn't really matter. 5 and 6, and I know one of those has to be a negative. If this is a positive 1, then I know that it's got to be a negative 5. 6 minus, or negative 5 plus 6 is 1. Or you can think 6 minus 5 is 1. There we go. All right. I wrote it in another way. It means the same thing. The product is the same as thinking what two numbers multiply to. The sum is the same as thinking which two numbers combine to. So we think the same. What two numbers multiply to a 36 and make a negative 12 when added? It looks like both the same sign and both negative to me. So I'm thinking of 6, but I'm sorry, it's negative 6 and negative 6. That product is positive 36, and negative 6 minus 6 definitely makes a negative 12 when combining them. All right, this one's interesting. The sum is 0, and the product is negative 25. So don't think the same sign. Remember, they got to be different. And I'm thinking something like 5 and 5. But how do those make a 0? if one of them is negative. So that's one that's somewhat of a special case. We'll talk about what that means more later. All right, 2 more here so we can move on. But if you're understanding these the idea behind these little number puzzles, I think you're ready to understand the concept if you're not familiar with it yet. All right, the last two, or let's begin. We have a -4, or I'm sorry, I'm some form of 4 and 5, it looks to me, because that 4 and 5 can make a -1 somehow if we experiment with the signs. So we want negatives 1 as the remainder, so this got to be 4 minus 5. That's the only way that can work. And then this one down here, multiplied to 100, combined to 20. It looks like 10 and 10. And this time they're both positive, okay? Because 10 plus 10 is 20. All right, that was it. That's the main idea behind these. You can just always check them yourself. And let's see how that will apply by first revisiting, like I said, our good old friend, the distributive property. Here we go. One of the ideas from the last video, and again, I want to go a little bit faster. If you're not familiar with the shortcut, if you are familiar, you'll see something that you've seen before. So just bear with us. All right, distributive property one of the most basic examples I can give you is this. We'll take this x and distribute it to the entire expression inside that parentheses. And remember that distribute, the operation implied is multiplication. So we mean x times x. What's x times x? It's going to be x squared. All right, we know that. And x times 5 can also be represented x times 5 or 5 times x, 5x. And that's it. That's the 2 terms that we get when distributing this or multiplying this x term to both of these. Similarly here, we have a -2 that's being multiplied to both of these terms. I'm going to do that in yellow. Okay, so this -2 times x, -2 times the first term is -2x. It's important to write those symbols, especially when it's negative. And -2 times positive. Remember the idea that negative times a positive is negative. And 2 times 5 is 10. So check those, hopefully in your head, or if you wrote them down ahead of time. And the idea is if you're able to do these two separately, then we're able to do this type of problem like this, where it's 2 terms inside the parentheses of each expression. So something times something, but each one of those somethings is an expression that involves 2 terms. Those are called binomials if you're interested in that. But let's look at the idea first and use the same color coding. Let's first distribute this x to the term on the right side. And look at that. We did that before. It's the same 2 terms from here. That's the main idea there. So x times the first one is x squared. And then x times the second term, x plus 5x. And then separately, like we did in the previous to the left, we can take this -2 and distribute it to the right side, right expression. So that would be -2x plus 10. All right, there's the color coding. I think that's the last time I'm going to do it. I'm going to go back to my favorite color, I guess, or my standard. But the idea is, what if any of these 4 terms can be combined? Not that x squared doesn't have any like terms, but what about these 2 middle terms? Those are like we can combine them. Is there any other constants that can be combining with 10? And the answer is no. So we're just going to take a little bit of algebra here. Oh, that's not the color I said I was going to use. There it is. By adding those 2, we get 5 minus 2. 5 minus 2, be careful, is going to be a positive. So I'm going to write positive or plus 3x and then plus 10. All right, this is as far as I'm going to take it here. That's as far as we can simplify it and the main idea behind this. All right, so let's do that a little bit faster. And I don't know, I'm thinking about not using color anymore, but let's do it for a few. All right, if we take this x, we have to distribute it to the 2 terms on the right side. What would we get? Try to do it ahead of me or take some time to do all of these before and check them with me now. All right, so the first is x squared. Very similar, x times x was something we're going to see a lot. And x times -7, I'll represent it as -7x. All right, so remember that was taking the first term, multiplying to these 2. And to keep that same color code, take yellow here. +4 times both of these terms. So +4 times x. Again, it's important that I write +4x in this point of this expression. And then positive times negative is a negative number. And 4 times 7 is 28. So negative 28 is the product of those two. And again, hopefully you're seeing a connection. We're using the words product and sum often here. And then we just combine or take the sum. Look at that. We take the sum of those like terms. And our final result would be x squared. Negative 7, positive 4. We have more negatives remaining. And it is 3 of them. And then minus 28. I don't know if I want to box that yet. It's okay. And then, all right, let's keep doing some of this. A little bit faster. I'm running out of space here. Maybe I should write smaller. All right, distributing means multiplying. We're going to take the first term. N times n is n squared. And then negative 6 times n will be represented that way, negative 6n. Now, we take the negative 2 and distribute it to those two terms. Notice that when we distribute the green term, we get 2 green terms. When we distribute this yellow, we get 2 yellow ones. So minus 2n. And then negative times negative, be careful, that's a positive, and it is positive 12. Again, we're going to take our sum of the like terms, and n squared. Negative 6 minus 2 becomes negative 8. And then plus 12. Cannot be simplified further. Okay, good. Did better with space that time. All right, again, now we're going to distribute this k to both of these terms here. And k times k will give us k squared. Then k times negative 3 can be written as negative 3k. Next, we will distribute 10 to both of these terms. First term is plus 10k. 10 times k is plus 10k. And positive times negative, note it should be a negative number. And 10 times 3 is 30. And that was our product. Now we take our sum of like terms. We get k squared. Positive 10 is bigger than 10 is bigger than 3. Therefore, we remain with more positives, and it is 7 of them. That was a bad sequence, but hopefully you follow my thinking here. All right. And last one here. I guess I'll stick with the color code. I'm not that bad at it. P will be distributed now to both of these terms. We get P times P represented as P squared. Then P times 8 can be represented as plus 8P. And now we will distribute this negative 3. Remember, it's not just the 3 that's being distributed, it's also the negative. So negative 3 times P can be represented as negative 3P. And then negative 3 times 8 should be a negative. And negative 24. Remember that negative times positive is negative. And that was our product. Now we will take our sum. Our sum is 8 minus 3. More positives remain. How many more positives? 5 of them. And minus 24. There it is. All right. The goal for me at this point, and if you need more practice, that's fine. Take your time with this. But the goal for me at this point is not only to stop using the color code, but matter of fact, just skipping all this work altogether, because the answers are pretty much given to you. Or they're right there hidden at the beginning of the problem. Not gonna lie. So let's explore some of that actually. So take a mental picture of this because it's going away. I'm gonna erase all the work and just leave the answer down right now. And my goal is to start doing them that way. Okay. So let's explore something here. Yeah. Let me take my wrong function here. Let's try. Like I said, I'm gonna remove my work. There we go. That's gone. We're not going to be able to look at this anymore. That one is also. And I think we got one more thing to erase here. I'll do it like this. Okay, great. So here's the thing that we should think about, okay? This is the original problem here. Something times something, and here's the answer. I guess I should box it so you can, just that one, because the other ones you can follow. All right, here's the original problem. And here's the answer, okay? So the question is, look, the x times x squared, that's very easy. It's very easy to see where the x squared term came from. But can we quickly see where the positive 3 came from? Do you see a positive 3 hidden up here in the original problem? And the other question to think about is, look at this. This 10 is also hidden up here. I think I see a mistake here. There we go. Let me fix that. Oh, guys, you didn't tell me earlier. Positive times negative is negative 10. There we go. Good thing we caught it right now. Otherwise, that's doesn't make any sense. It's negative 10. There we go. Now we have that. Okay, do you see a negative 10 hidden in the original problem? All right, but look, it happens down here as well. With this problem, do you see a negative 3 hidden in the original problem? How could that be? Do you see a negative 8 hidden in the original problem? How do we see a negative 8 up here? Do we see a positive 7 up here hidden in the original problem? How could that be? And the last middle term is 5. How can we see a hidden 5 up here in the original problem? And do we find it the same way every time? The negative 3, the negative 8, the 7, and the 5. What was that? We did the sum, or we combined a negative 7 and a 4 to get a negative 3. What's the sum of negative 2 and negative 6? It is negative 8. You see that? No need to show all that work. What is 10 combined with negative 3? Or 10 minus 3 is positive 7. And what's negative 3 plus 8? Or that sum is 5. So hopefully you were thinking sum to get the middle term, or that, not necessarily the middle term, the term associated with the variable of p, or just k, or n, or just x, not the x squared one. That's the association, all right, with that variable. We're just taking the sum of the original integers given in the problem. And the last question that we want to answer is, how do we get this negative 28? And how is that hidden up here? Think of the 12. How is that hidden in our original problem? Think of the negative 30. How's that hidden? And again, it is just like all the other ones. There's a negative 24 hidden up here. And hopefully you were thinking, are we doing the same thing to get that number? And what is the operation, or what is the thing that we're doing to get that? It's called a multiplication or a product. All right, so I'll just summarize it on one of them. And hopefully that you were thinking, to get this middle one, or the one associated with just k, we did a sum. And to get the last term, we did a what? A product. If you prefer to think combine, the numbers combine to 7 and the numbers multiply to negative 30, that's also fine. That's perfectly okay. But that's the idea. To get our last term, we're just going to multiply those. So let's try this idea, but a little bit faster. That's my thinking, so that we can see how we will be doing this from now on. All right, great. So remember, the first term is the easier one to get. What's m times m? That's not going to take a lot of thinking then. There, m squared. And the idea was, what do we do with these two numbers to get our next term, or middle one? We took the sum. So be careful when you're doing the sum, because even if you're thinking sum, but you do it incorrectly, and you write like positive 1 or negative 1 here, that's wrong. Because what's a negative 4 and a negative 5? It's a negative 9, and negative 9 what? Negative 9m. Remember that it's still going to be what a term with the variable associated with it. And lastly, we do a product. What is a negative 4 times a negative 5? It must be a positive number, and that was 20. And there it is. Look how much faster we can get there in pretty much one step. I want to redo that because I know that I will probably need more space. But try to do the next few on your own if you need to, ahead of me. If you need to check them, let's do that now. All right. So the first term we will get by thinking, this is a t, by the way, t times t. So you can differentiate my t from my plus sign. I add a little curl at the bottom of the t. So therefore we will get t squared. And then we will take a sum. What's negative 3 plus 14? That is positive or negative? It is positive, and it is positive 11t. And lastly, we take a product. Negative 3 times 14 better be a negative number. And I think that's negative 42. All right. Look at how fast we did that. Right here, something times something. But this one's a little special because unlike the other ones, this something right here is not the same as this something. This something on the left is not the same as this something on the right. But look at both of these on the next expression. Are those the same? Yeah, that one's special. And what's x times x? It is x squared. And a plus 8, it is a plus 16. And then a times 8, both positive, give us plus 64. And why is that one special? Because it is the same thing. It can be written as something squared. That's very powerful in this quadratic, in this course of whatever level of quadratics. And the something is x plus 8. So always think that if it is a perfect square, it's a very special case because it is a perfect square. All right, so all three of these are equivalent to each other. And then the next one, is that a perfect square? Almost, it looks like it, but the answer is definitely not a perfect square. This minus 7 is not the same as this plus 7. So let's just simplify the way that we know. Y times y is y squared. And then what's negative 7 plus 7? It is 0. So in a way, I'm going to write it as plus 0y because it is plus 0y technically, and then minus 49. But hopefully you think that plus 0, if you are thinking 0, is plus 0y. So really this is just simplified to y squared minus 49. So in a way, that's also kind of a special one because all the other ones before had 3 terms as the simplified form. Look at that. All the other ones before were able to simplify to 3 terms. And this one was able to simplify to 2 terms. So that's kind of cool, actually. All right, look out for those. These last two are a little bit more special than all the other ones, all right? But we will talk about those cases more later. Special, I don't even know how to spell that, so let's just leave it out. Let's keep going because the concept is more important than calling them that right now, but just keep it in your mind, all right? All right, and I do want you to think, all right, we did a lot of distributing, meaning multiplying. We even developed a shortcut because now we want to think the opposite. We want to undo that. We want to think, what's the opposite of distributing? So you got to think, what did distribute imply in the first place? Remember that it implied multiplying. So it is okay to think, what's the opposite of multiplying? It is dividing, but not necessarily, all right? Dividing, we'll say it's some form of dividing for what we're going to do right now. We'll say some form, okay. Or you can think undistributing if you prefer. Sometimes I use that term with my students. What's the opposite of distribute? Undistributing. But you do want to think some form of dividing. All right. And if you have heard the term of really that term is called factoring. Right. So really we are doing factoring. But I do like to think division. It helps a lot with this. All right. And now we're just reversing what we did before. Notice how we're starting with what the answer looked like. So that means that we must have started with something times something. Another thing I would recommend, I chose these purposely not to have that case, but always check for a GCF, greatest common factor, before doing this type of thinking, all right? These don't have any GCF, so we're okay. And again, look, this looked like the previous type of answers we had before where it involves 3 terms. So it must have been something times something. Let's start to think that way. And remember, for the last part, how do we usually get our middle term of -6 or -13 or +4? With a sum or a product. That was a sum. So we're looking for 2 numbers. And again, maybe I can start here on the left side. First of all, I would ask, how do we get this x squared term? What do we multiply? X times x. That's the easier one to figure out. And then we have to figure out 2 quantities here. All right, like we did before. We started with something that was more advanced than just x. So we think those 2 numbers have to have a sum of -6 and multiply, or a product of -16. I like to start with the product. All right. This one will say that, let's just stick with one. All right. Can you think of 2 numbers whose product is -16, but could have it combined to -6? And hopefully we're thinking. You can go ahead and think of it ahead of time. Let's check now. Hopefully you're thinking some form of 8 and 2. I think that will work because 8 times 2 is 16, and 8 times 2 can make a -6, but only if 8 is bigger, it's greater in quantity. And this one is positive. So let's check that. That will work. What's +2 minus 8? It is definitely a -6, and +2 times -16, times -8 does in fact check to become a -16. So that one is done. Notice how we undistributed that. Or we factored it, right? We went from a final answer from the previous example and we undistributed it. That's excellent, right? Okay, but only because we know that thought process, that the product has to be the last number and the sum has to be the middle number, that the middle number has to be the sum and the last number has to be the product, but only if they're written in that form. Okay, so be careful. This is, suppose that someone's trying to trick you and write it like this: n squared minus 45 plus 4n. Hopefully you see that you should still be thinking sum here. This is the sum and this is the product, because someone can try and trick you like this. All right, so just be careful with that. All right, let's think. Let's move on. What did we get to, what did multiply to get w squared? It better be a w times w. And now we're thinking product of positive 40 and sum of negative 13. So some of the common choices might be, oh, 10 times 4. 10 times 4 can multiply to 40, but can 10 and a 4 ever make a 13? No, that's not going to work. And hopefully you thought you went through some thought process and say, how about 8 and 5? I haven't tried that one yet. Can 8 and 5 multiply to a 40 and combine to a negative 13? Yes, only if they're both negative. And you check it, negative 8 minus 5 is negative 13. And then negative 8 times negative 5 is positive 40. So there it is. That's the factored form. Or the undistributed form, if you like to think of it that way. I'll box it to indicate that is it, but there's no need to do that. And again, I don't like to think of it as this top format. If it was given to me in this format, I would rewrite it in this format below and say, all right, I know that I multiply something times something to get that. And how do we get n squared? By multiplying n times n. And then I'm thinking product, because always think product first, because it limits the choices to a smaller number of them. And something that multiplies to negative 45 and combines to a positive 4. Hopefully you're thinking some form of 9 and 5. And then we have more positives, therefore positive 9 and negative 5. Always check, negative 5 times positive 9 is negative 45, and 9 minus 5 is 4. That one is done. All right, let's try these here. I won't be boxing them anymore. I'll just write down the solutions in green. Or you can try them yourself, pause at this time. But either way, let's check now. All right, something times something. I recognize all of these because there's no greatest common factor. If you don't know what that means, I'm going to do another coming up video that talks about a lot in detail. But it's not required for this practice, so that's great. Hopefully you were thinking k times k for this one, and then x times x for the next one, and m times m for the third one. And remember, I always like to think product first. It have a product of 48 and a sum of positive 14. Both of these being positive tells you right away that both of those are positive. And I'm thinking something like 6 and 8. And hopefully you check it. 6 times 8 is 48, and 6 plus 8 is 14. That one is done. Next one has a product of negative 80 and sum of positive 2. So it tells us opposite symbols. And what numbers can work here? Some form of, looks like some form of 10 and 8. And can 10 and 8 make a positive 2? That's right, only if we have positive 10 and negative 8. 10 minus 8 is positive 2. And 10 times negative 8 definitely works. That one is done. Oh, I like to point out, if you ever write these in the opposite order, like x minus 8 times x plus 10, that is the absolute correct answer. They're the exact same thing. Multiplication, the order doesn't matter. Remember that we're multiplying something times something else. So the order in which you write them doesn't matter. For any of these, if you reverse the order, as long as they're the correct symbols, however, all right? So for example, on this one, don't do this. Don't do, oh, this one becomes x plus 8 and x minus 2. All right, that's not the same. So don't do that. That's wrong. So I will erase that, pretend it never happened. But think about that. All right, next we have something that multiplies to a negative 30 and combines to, be careful, this is a minus m, but it's really the number you want to think about is a minus 1. If you need to write it, go ahead and do that. Or think about it in your head. So combines to a negative 1. So those numbers better be only 1 unit apart. It looks like a 6 and 5 will satisfy that. And negative 6 has to be larger to get a negative 1. Or 6 has to be larger to get a negative 1. I'm sorry, that's what I meant to say. And that's done. Okay, that's the idea of factoring. That's pretty much the gist of what you need to understand about this video. But I'd like to show you the next two examples. They're not going to be very long. But what we will do with this, because these two ideas of distributive property or distributing and factoring will be used in almost any course that you go on forward from here. All right, so let's just see how it can benefit us soon. And the idea is that we could solve equations of quadratic format by factoring. Look, we have already seen some before. This is already in factor form. Something times something is already called factored form. And remember that we say, oh, the answer is equal to 0. That's nice. Either the first something is 0 or the second something is equal to 0 or both. So that means that we have x equals, what makes the first something equal to 0? It is a 9. Or what is the other option? It is a -7. Hopefully you remember how to do that. We have a video on that before. Go review it if you forgot. Okay. And again, but this one's not in factored form. So now that it's making us think of a further step before we can proceed. All right. And we think of something that multiplies to -80 and combines to +2. I feel like we did that before. And yes, we did. It was 10 and 8. And it was a +10 and a -8. I think I even switched my order, not on purpose, but look at that. Oh, I wrote them in both orders before. It's okay. And that now gave us a something times something equation that we know how to solve from before. That means that x equals 8, or our other option is x equals -10. And that is done. And lastly, we have the same kind of thinking, but with a different variable that doesn't make it any different. We still think something times something equal to 0. M times m gave us the m squared, multiplies to a -30, combines to a -1. What is the pair? It is a -6 and a +5. I think we did that one before. Let's check that. Yep, we have the same thing. And then that means our two solutions are either m equals a +6 or m equals a -5. Just to give you a little preview of where we're going. I'm not going to do more examples because there's another video coming up devoted to just this idea on its own, okay? To practice more factoring, of course. And one of the things that you may not see, some of these, one of these you will not see in the quadratic course, but how we will use quadratic distributive property later is this one you've seen before, and it's just x times x is x squared, and then x times -8 is 8x. But this one we will also see in quadratic course for sure. We have a -4 times x squared is -4x squared, and then -4 times +3 is -12x. So this kind of form we will see later, and -4 times -2 is +8. And then this one is not in this course, but I like to show you if you're curious or want to see how else we can use this. I remember the idea that it means we must distribute this x to, now there's 3 terms on the next one. So we're going to distribute it to all 3 of these, all right? And I'm going to write it in green. For the first one, we have x times x squared. That is x to the 3rd. If you don't know how I got that, that's not the purpose of this video. Go practice exponents. Then we have x times -4x, which is -4x squared. And then x times, the last one is 5, gives us +5x. Notice how when I distribute this x, I must get 3 terms back since I did it to 3 terms. And I will use yellow now to show the 3 terms that I will get when I distribute this +3 to these 3 terms. And 3 times x squared, I can write it, I'm running out of space and I can write it here, but I'm going to match the powers, all right? So I'm going to write +3x squared. And when I say that is, this x squared power matches with this x squared power. It wouldn't make sense for me to write it here, then I wouldn't be able to combine them. And then +3 times -4x, that will give us a -12x. And notice how now that lines up my x terms to be able to combine those. And then +3 times +5, it is a +15. And notice that there will be no more like terms. There's 2 pairs of like terms. I'm going to add them vertically like this. Is there any like term to x to the 3rd? Analyze all of them. There is none. So I'm just going to bring that one down and have x to the 3rd. That's just down by itself. But the idea is that, look, now I can combine both of these. -4x squared and +3. Do we have more positives or more negatives? It's going to be more negatives. How many more negatives? Just 1. So I like to not write it as -1x squared. I'm going to write it as -x squared. And then I can combine this. We can combine +5x and -12. Who has more? The negatives. The negatives have how many more? 7. And that like term is x. And lastly, we have plus 15. So notice how when we use distributive property to another level, it gives you a result that's even more complex. Look at that. It's kind of cool ideas, all right? All right. So that's it for this video. Stay tuned for more, and I like to show you more of what I know.